Hello, how's it going? In this video, we are going to apply some basic transformations to our objects, our quad and our triangle. Now, I know that with a lot of these videos, I say settle in, you're in for a long haul, but in this video, that really is true. I'm not going to be focusing so much on the mathematical aspect of making transformation matrices. I'm going to take that as a given because there's already definitely enough to talk about when it comes to the logistics of getting matrices onto the GPU. There are a few stages here. We're just going to take it one step at a time. So first up, I'm just going to open up my shader and I'm going to declare another resource which will be bound. So this will be a different binding group. So this will be a uniform. Its name will be model and it will be a 4x4 matrix. And what we can do is down when we get the position, we can just apply that transformation matrix. So usually I like to group bindings. So my binding groups, I group them according to frequency of binding. So this texture and sampler would be bound on a per object type basis, whereas this uniform matrix would be bound on a per draw call basis. And then later on, when I start doing perspective projection and view transformation, so I can make like a floating camera, then that information would be bound on a per render pass basis. So that would be in a separate binding group. But anyway, that's the shader done. So some of this is going to be a little bit awkward because I was having trouble getting modules to work properly. But the basic idea is I now want some sort of representation of the objects in my world. This might be referred to as like a model module. So I'm going to make a folder called model. This is for modeling the game world. And then inside I'll put the usual module description and file. So I'm just going to call this game object. I'll go declare a public module called game object. And then in my main, I will use that. Okay, so the game object is pretty straightforward. I'm going to have a position and angle, basically, and this can be either for a quad or a triangle. I'm going to use a vec3 for position, which is why I'm using this here. So anyway, I'll have a public struct named an object, I guess. And for its fields, we'll have position, which would be a vec3, and then angle. And I'll keep it simple. This will just be a float. So over on the main section, I'm going to add in a world struct. And this world will basically just, as it sounds, this will just represent and manage a bunch of game objects. As far as the constructor goes, this will be pretty straightforward. We'll just basically make empty vectors, initialize it, and send it over. So we'll go construct the world, and for the quads, we'll just have an empty vector. And the same for the triangles. Then I'll have an update function. In my situation, I'm just going to make the triangle spin around. I don't care too much about the quads. So we'll look through all the triangles. So pretty much the simplest update function you can think of. We spin things around, just keep them in the range 0 to 360. No particular reason to do that. Just looks nice, I guess. So yeah, that sort of is how our world is going to manage a bunch of game objects. So as for how these uniforms are going to be represented on the CPU, on the GPU, there's something called a uniform buffer object. That's a buffer, or in our case, a region of a buffer, which can be bound to a bind group and then applied, visible, just like any resource. Now, I'm using buffer suballocation, and what that means is, let's say, for instance, we've got a buffer which has a whole bunch of data. This gets allocated up front, but then some region of the data gets used for resources. So this one is some region of the larger buffer, which has been set aside as a bindable resource, and it itself can be treated like a little buffer, even though it sits on a larger buffer. And then, we can go in and allocate another subregion of that buffer as a bindable resource. But there's a bit of a trick that I'll get to. But the basic issue is that in reality, these uniform buffer objects have requirements in terms of alignment. So it turns out that a 4x4 matrix takes 64 bytes, but the minimum alignment for a uniform buffer object is 256 bytes, which means that we can't have these things tightly packed the way we got them. It would be something like this. Something like that. So there is a uniform sort of spacing. The buffer is allocating more space than is required, but the upside of that is that if these resources take more space but still fit within the alignment, then it's not an issue. They can grow up to 256 bytes and they will all fit in one chunk. But I've talked enough, and I understand that's a bit of a weird concept, so let's just jump in and make this thing. So I'll go into the renderer backend and I'll make a new file. I'll call it uniform buffer object. And of course, I'll have to export that. So I'll go ahead, I'll make a public struct uniform buffer object. And I'm going to need a few things. I'm going to need a buffer, and then I'm going to need a set of bind groups, because the buffer is the large resource, and then the bind groups are describing regions of the buffer, which can be bound like descriptors. And then just as a quality of life thing, I'm going to query the requested alignment of the device up front upon creation, and I'll have that later on when it comes time to uploading. But I'm going to need a few things. I'm going to need so super will get me back within the same level, and I'm going to use the bind group module, and I'm also going to need a function. If I go over to mesh builder, there's this any as U8 slice. That's a pretty useful function. I should probably be refactoring this better, but I'm just going to make it visible, and I'll hang on to that as well. So for the data types of these things, the buffer will be a pretty much WGPU buffer. The bind groups will be a vector of bind groups, and then alignment will just be a U64. Okay, so this constructor is going to be a little bit involved. I'm going to need to take in, a device. I'm also going to need to take in an object count, because this UBO will actually be allocating for a whole bunch of UBOs. We need to know how many objects are going to be drawn in order to know how many matrices to give space for, basically. And then additionally, this UBO, because it has a bind group, is going to need to know which bind group layout it conforms to. So we're going to have a layout as well. Okay, so first up, I will query the alignment. So there's this limits function of the device, which basically can be used to query anything we want at all. And in this case, I'm using it to look at the minimum uniform buffer offset alignment. But I'm going to balance that against the size of the data that I'm sending in. There we go. I'm casting both of these to unsigned 32 bits because that is the argument type expected by GLM's max function. But then we can go ahead and start describing the buffer. Okay, so typically in this case, when calculating the size, if we've got 3 objects and every matrix is 64 bytes and we take 3 times 64, but because we need to possibly have a different alignment, in this case we definitely do, then we'll just use the alignment variable. And even though we're just allocating 64 bytes, there will be extra padding, but this is a requirement of the GPU. We have 2 flags here because not only are we going to be using this as a uniform buffer, but we're also going to be uploading data to it. Now, just to note, this copy destination is for a queue copy. So, copying from a buffer, copying from a texture or something from another GPU resource. If we were to upload from the CPU without using a queue, then we would create a mappable buffer. But I'm not going to do that. Okay, and this map to creation just indicates, hey, do we want this upon creation to be ready to go to give an initial data upload, which we're not going to do. But we can go ahead and then create the buffer. Okay, with that done, we'll then need to create a bind group for every object. Okay, so I'm going to need to go back to that bind group builder for a second and add a function. So if we go back to the bind group builder, we have functions to add all of these resources. And the function that I'm going to add, besides being able to add materials, is I also want to be able to add a buffer to a bind group. Okay, this looks fine. So I'm going to create, a buffer. And then for that, I'm going to need a buffer binding. It tells me here I'm going to need, a buffer and then an offset. So I'm going to need to put in an offset as well. I think I can get away with this. Yes, I can. Okay, so maybe not great, but we can put in size none, and I think it'll try to work things out. Okay, great. So then back on the EBO side, we'll go and add a buffer. I'm going to have that buffer there, and then for the offset, I'll go I times alignment. That's fine, and then bind groups. And then finally, we can actually construct that struct. Okay, so this sort of function allocates all the space and creates all of the bind groups to describe, the matrices which will go in there. But then the next thing is I'm going to need to be able to upload a matrix to this. So I'll have a function called upload, and of course we're going to need the thing we're uploading to, the position that we're uploading to, the matrix number, the object number, the matrix we're uploading, and then I found the easiest way to do this is to submit a job on the work queue. Okay, so I'll work out the offset into the UBO, into the buffer that we'll be uploading to. That will pretty much be the matrix number times our alignment, and then I'm going to have the data that is going to be uploaded, and I can do this with the the any as you wait slice. Cool. With that, I can take the queue and then submit a job to write to that buffer. We need to specify the buffer that we're writing to, the offset, and the data, and that will go ahead and submit the job. Well, not submit the job, but queue the job up for submission. So pretty much that is our uniform buffer object. And I'm going to need to make some slight adjustments. Just going to go over to the bind group layout, and I'm going to add a function to add a UBO. So I'm just going to change this vertex, and then for this, that'll be a buffer. The TY will be a buffer binding type, so W, and that will be a uniform buffer. We are not going to have dynamic offset. And then for the minimum binding size, I think we can just put in none. I think we can get away with that. Okay, this all looks good. Now let's go over to the renderer. Okay, so here I'm just going to add another variable called UBO. That'll be, I should probably import this. So I'll just go up to the top. But the deal is that I'm going to create my renderer, create my world, and then tell the renderer about the world. And so this will be an optional thing. We can just start it off at none. That's perfectly fine. So just looking through, we go through, this is a lot over here. But I think the big thing is, as well as a material bind group layout, we're going to need a UBO bind group layout. So I'll go ahead and add the UBO, and then down below I'm going to add a second bind group layout to the pipeline. This all looks good, and then for the UBO I'll just put in none. That's perfectly fine. So now I'll make a new function down here, which will basically be for telling the renderer about the world. So we sort of don't care what the actual objects are at this point. We're allocating space, so we just care how many of them there are. Now I'm just going to go up above and grab that code again where I made that bind group layout. So I won't worry about this stuff for now. Sort of ticking through. I know there's a lot. I'm looking at the time now. This is going to be a long video. I'll try to edit it down a little bit. So the next bit is rendering. So the funny thing is, I'm going to do a few stages. First up, I'm going to construct and upload the transformation matrices for all objects. Oops, I've forgotten something. Now when I render, I'm also going to need to take in the set of quads and triangles to render. So I'll have quads, which will be a reference to a vector of game objects, and I'll have triangles, which again will be a reference to a vector of that. Okay, so then I'm going to go through for all the quads, and this is a little bit cumbersome. I want to make, basically I want this. I want some matrix, and I'll do that by, if I go up to GLM, no way are we using that. Go up to GLM, there's a module within GLM named extension or extended or something, and this has all the matrix transformation functions in it. So I can go X rotate times translate, whatever that stuff is, that'll make my matrix that I want to upload. Then I get my UBO, and this is a little bit annoying. It's actually very annoying. So I upload to position I, and then I upload the matrix that I just constructed, and that gets uploaded to the queue. Then I do the same thing again for the triangles. Then after that, I'm going to send, or basically, then after that I'm going to submit all of those uploads for completion. So I can go get the queue and submit, and you can do this. You can just send in an empty set of command buffers and it will just do its thing. But then I need to wait for that to complete, like do synchronization. And I'm going to do this, I'm going to do this in a little more verbose way. But this submission operation actually returns something called a submission index. And then we can make a, you call this a behavior flag or something. It's called maintain, so WGPU maintain. And then there's a few options. There's a few. There's wait, and then wait for, poll, wait, and wait for submission index. Now poll just means that when we query, when we poll the device, this will indicate true or false as to whether the device is currently working or not. If we choose wait, then polling the device will cause the device to wait for the most recent submission to have completed, which in this case sort of is what we want. But I'm going to be a little more verbose. I'm going to wait for that specific submission index. Again, not necessary, but that's what I'm going to do. And this will all be enforced when I poll the device. Let's pass in, whoops. Yeah, I just pass in that object there. Cool, so that will do my synchronization. Now, if I'm doing like exporting to WASM or something, then I believe on the browser this stuff automatically gets synchronized anyway, but I'm on desktop, so I'm going to do it this way. Now, this next bit, I'm going to sort of start chipping away at these messages. Okay, that's good. And then for that I, because that's a U size here, but I need it to be U64. And clearly I can't just go 0, 1, 2 and then 0, 1, 2 in this case. I'm going to need some sort of offset. So what I could do is I could do quads length plus I, but then if I add in another object type, it'll be quads length plus tries length, and that just gets a little bit annoying. So what I'll do instead is I'll make an offset variable. So start that off at 0. And then after I've done all the quads, I'll record I'll increment that offset. Okay, so now for this stuff. This gets really annoying. So let's start with the angle, right? So for the angle, we'll get, what's angle? For the axis of rotation, that will be around the z-axis. And then for the translation amount will be the position. Okay, now as for these m's, this works pretty much the same way as GLM. Like usually you would put in an identity matrix. Now the issue is, for some reason that I do not, let me just quickly check this actually before I say this. So for some reason, the GLM Rust crate just doesn't seem to have a function for creating an identity matrix. I don't understand why. If we go, we have all these functions. We've got new. We have inverse. We don't have identity. Isn't that weird? And if we go new, we need to explicitly put in vec4s for each of the columns. Again, so here we've got X, which has our translation, rotation, all of this, but it doesn't have identity. It seems like am I missing something? It seems like a very easy thing to implement, which would be a big quality of life improvement. Which is why I'm going to copy paste this. So this is my hacky way of making the identity matrix, is I construct all the vectors, the columns by hand. And I do not like it, but it works. Cool. So we make those matrices, we pass them in, they do their thing, we upload them. Okay, let's say that all works. We then submit that and synchronize it. The next job is in here, we're going to start actually rendering. Okay, so in this inner scope, we're in the rendering stage. In here, we are getting ready to render a quad. So I'm going to swap that out with this loop here. Okay, so I'm going to set the bind group for the render pass, and this will just basically bind the bind the model transform that we uploaded before. So this will be bind group 1. The bind group we're going to send in, again, I really don't like this, but we go our UBO, there we go. So a bit of typing, but basically, yeah, bind to the bind group and then issue the draw command. Now we'll do something very similar down here. Cool, okay. And then, right, so now we'll just have to go in and put all the pieces together. I know there's a lot of writing. The conceptual stuff is sort of out of the way. We're on the home stretch now. Okay, so first up, let's go ahead and make our world. So I'm just going to push the quad a little bit off to the right, but it's not going to have any rotation. And then I'll add a triangle which is centered at the center of the screen, and it's going to be spinning around. Then I'll go ahead and tell the state to build UBOs for 2 objects, to expect 2 objects. Then in my main loop, I'll go ahead and update the world. I'll hard code this in. Assume it's running at 60 frames per second. That may not be accurate. And then when it comes time to render, I will just pass in references to the worlds, quads, and tries. Okay, so moment of truth. Let's see how this goes. Okay, nice. So what's going on here? It's a little strange, but we've got this object. Now the reason this is sort of stuttering, I think it has to do with the frame rate. I think the frame rate is uneven, but it is sort of working. The quad is a little bit off to the side. The triangle is spinning around. It's a little messed up, but that's not too bad. Okay, so I'm going to leave it there and have a drink of water or something, because that was full on. But anyway, as always, have fun, keep coding, and I will see you again soon. Bye.